So when you see this, it's nothing to be afraid of. All of that means is it's a summation. Okay, it's a series where you're adding terms. Okay, so that sum means sigma means sum here, which means you're looking at a series. Now remember, a series is where you are adding terms as opposed to a sequence where you've got terms just written of an arithmetic or in a geometric sequence or any sequence, for a matter of fact. So in order to add all the terms, well, what terms are we adding? We're adding from the first term when r is equal to 1 to the term where r is equal to 20. And I always say when you're starting off these sequences or these series is to be precise, is actually write down the first few terms. So what is the first few terms, and then actually work out, is it an arithmetic? Is it a geometric? Is it a mixture of both, which you can get? Or is it just not either of those, i.e. it's a recurrence relationship, which might mean that you've got some sort of oscillating sequence where it's repeating. Okay, so you need to figure out what type that is, and you can't just go and straight away jump into a formula. You can't just go and use Sn of the arithmetic or geometric. You need to actually start by writing down the first few terms to figure out what's going on. So when r is equal to 1, when r is equal to 2, when r is equal to 3, when r is equal to 4, why am I starting off r equals 1? Because they told us to start off at r equals 1. If that wasn't r equals 1, if it started off with r equals 5 to 20, then I would have started off with r equals 5, r equals 6 to figure out what the first few terms of that series is. So let's go and see what the first few terms are for this. So when r is equal to 1, 3 lots of 1 plus 10, that's 13. So I'll write down here what I'm working out. I'm working out the value of 3r plus 10 in each case. When r is equal to 2, it's 3 times 2, 6 plus 10, 16. When r equals to 3, 19. When r equals to 4, 22. So straight away we can see here that the terms are all increasing by 3. So we've got a common difference here. And this is what I then use to conclude that this is an arithmetic sequence. Okay, so we have an arithmetic. Now that I've actually established what type of series we have, I can then go and use my summation formula appropriate to that series. So then I can go and use Sn is equal to n over 2 and use the appropriate formula for it. So never jump into it. Always do this step here right at the beginning, the step where you are actually writing down the first few terms using that formula given to establish what type of series it is. Okay, and then the rest actually then becomes, the second part becomes quite straightforward, just application to a particular formula. So what I'd like you to do in this instance is have a go at question 17 using that same thing that I said. Write down the first few terms, and once you've established what it is, write down the appropriate formula for it. I don't want you to work out using the formula. I know you can probably go and do that. It's not a difficult thing to do, but I want you to just focus on that first part for these A, B, and C. Lay it out in the same way as I did if you want to. So this one starts from r equals 1, so you'll write down r is equal to 1, r is equal to 2, r is equal to 3. You write down the formula you're using, r squared plus 1. What is the terms? Find out what type of sequence it is. Do it for the second one. So I'm going to get in. So let's move on from here. You should have got those values just to consolidate here. This first one, when r is equal to 1, you get 1 squared plus 1, which is 2. 2 squared, 4 plus 1, which is 5, 10, and then we get to 17. And to see what type of sequence it is here, is it is it an arithmetic sequence? Is it well, it doesn't look like it because it's not adding by 3 each time. So is it maybe then perhaps a geometric sequence? Well, let's take a look at it. Is it a geometric sequence? Well, it looks like there's a, is it timesing by the same thing each time? Well, from 2 to 5, it's times by 5 over 2. So then from 5 to 10, it's not times by 5/2. So it doesn't look like that first one is either an arithmetic or a geometric. So it might be actually a mixture of maybe two things. So you could potentially write this as sum of r squared plus sum of 1. So I've essentially split up that bracket. Where you have addition and subtraction, we can split it up in this way. Because addition of two sequences, you can do it separately or as a combined thing. Same can't be said for multiplication. You can't split up multiplication like that. Okay, only with addition and subtraction. So then would r squared have been a particular type of sequence? Well, we can take a look at that. So for instance, if we had r squared, if we did split that up into r squared and 1, r squared would follow as 1, 4, 9, 16. So it's actually following a not even neither a geometric nor an arithmetic. It's a quadratic sequence, as we can see here, r squared. Okay. So how can we find the sum of this? Is there a particular formula? Do we know a particular formula for finding the sum of quadratic sequences? No. I sure haven't taught you anything like that. Maybe you've learnt it, but it's not in our syllabus. So we use what formula, like thinking, oh, what formula am I going to use? It's neither of those. Well, look at this. It's just summing the first 5 terms. So really what you needed to do then is find out what r equals 5 is. And then essentially just kind of, well, the sequence for 1 is just 1, 1, 1, 1, 1 all of the way through. That one would have been 25. So it's essentially adding all of this up. So can we use well, can't use any formulas. 5 terms, yeah, I could have had that, n is equal to 5. Nope, that doesn't apply, that doesn't apply. There are 5 terms we're adding. So you would simply do this manually, no other way of doing that. Because we don't know any formula for summation of a quadratic sequence. Okay, so you can get those things. And if you just go straight to a formula, and that's what I was trying to show you, if you just go straight to a formula, it won't work. Because you don't know what type of sequence it is unless you write it down. So this first step here, writing down the first few terms of the sequence, is probably the most important thing you can do with this sigma notation questions. Let's take a look at this. This is asking you to add 20 terms, so surely they can't ask us to add 20 terms manually. Most likely not. This should follow some sort of pattern. And if you did work this out, you'd work out what, 27 and then 31 and then 35, and you get the idea. This is actually going up by +4 each time. So this is an arithmetic, so I can write down here arithmetic. And since it's an arithmetic, I can actually write down what my first term is. My first term is 27. How many terms am I adding all the way from 1 to 20 inclusive? There are 20 terms there, so n is equal to 20. What's the common difference? 4. R does not apply because that's for geometric. So then I can go and use my appropriate formula for an arithmetic series. Sn is equal to n over 2. Get the idea. Third one, again, starting this time at n equals 19. Okay. So when n is equal to 19, what do we get here? Slightly bigger numbers so just substitute those in. Just get my calculator here. So 365 minus 5 lots of, well, 19 to begin with. 270. And then 265. And then 260. We can see here it's going down, the difference is -5. Make sure you write down minus. So what's the first term? Well, it's an arithmetic. We'll write down here arithmetic. So then we can use our Sn formula, n over 2, But how many terms do we have? Well, we got from 19 term to 30 term inclusive. It's from the 19th term to the 30th term inclusive. How many numbers are there? And this is again a place where there are mistakes made. Often students write 30 take away 19, which is 11, and they would write down they're doing the summation of 11 terms. But it's not, because you're including the 19th term and the 30th term. So in fact, it's not 11, it's 12 terms. Yeah, you count from 19. 19 counts as a term, 20 counts as a term, and so on. What's the first term of this sequence? We're using 270. The common difference is -5. R is not applicable to this. And then you would go and substitute those things into this formula, and that would get you the summation from 19th term to the 30th term. Okay? So hopefully that this exercise should have kind of identified the importance of this first step, to identify what type of series it is before we can go and do any actual kind of formulas and working things out. Otherwise you'd be working out the wrong thing. That first one, as we saw, was neither arithmetic nor geometric, but it's only 5 terms. Okay, if in doubt, and if there's only a few terms, just add them, find the first 5 terms, add them. You didn't even have to separate it on that first one. I know I did it like that to see if it was anything else, but it wasn't. Okay, sometimes separating it might result in a geometric plus an arithmetic. We have seen questions like that.